Hey guys, in this recording, we are going to do an example reviewing, just refreshing our memories on how to graph a quadratic function. The graph of a quadratic function is more commonly known as a parabola, and this quadratic function is in standard form. Now you might be wondering, like, why are we doing this? We're finding limits of rational functions. Well, when something presents as a rational function, you're going to have the ratio, rational ratio, right, of two polynomials. And sometimes, while it may present as a rational function, it may not turn out to be quite as classic as what we are accustomed to. We might not have that expected horizontal and vertical asymptotes and these branches and all that more common looking behavior. So this is to get us ready for some sneaky examples where things aren't always what they seem, but I want to make sure that we are ready. So let's get into it. Standard form of a quadratic function is commonly taught as y equals ax squared plus bx plus c. If we want to find the vertex, we would first find negative b over 2a for our x value or our input value. And then we take that value and we evaluate the function at that value to find our y value, the corresponding y value. A lot of times students make this way more complicated than it needs to be and a lot more overthinking than necessary at all. In order to find the y value that goes with an x value, plug in the x value and solve for y. It's really not rocket science, but everyone's like, oh man, I need the special like code key formula to figure out. No, don't be weird. Don't be weird. So usually we use f, but I'm going to use y of negative b over 2a. That just means the y value when this is not multiplication. No one ever told you that. That is not multiplication. Again, third time. That is not multiplication. I'm using it like function notation. I'm just saying the y of, or the y value at the opposite of b over 2a, whatever that works out to be. Okay, so there we go. We also should know that 4 is c, which is my y-intercept. And I also see here that a is positive 1, so my parabola will be opening upward, and x squared is a vertical not asymptote, parabola, meaning either opening upward or downward. If it were x equals and y squared, one, it would not be a function, and two, it would be opening horizontally, either to the right or to the left. But let's get moving. So I'm going to start out with x equals negative b over 2a. If I fill in my constants from this equation, opposite of b is negative 2, all over 2a. A is not x squared. It is the coefficient of x squared. Stop filling in x when you don't see a number because it's a 1 or a negative 1. Just fill in 1 or negative 1, okay? You don't fill in x's for this stuff. Don't do that. If you wanted to do that, stop doing that. Negative 2, 2 times 1 is 2, so negative 2 over 2 is negative 1. Now, x equals negative 1. If you leave something like this, that is a line. That is not a point or a dot or anything like that. That is not an x-intercept. What you have found is a line. In this case, a vertical line. That vertical line is the axis of symmetry, and you should, when you draw that on your graph, anything that's not a part of your graph must be dashed or dotted. You do not make it solid. If it's solid, it's part of the graph. And if I promise it's not, it's certainly not a function. We're graphing f of x. This should be a function when we're done. That's our axis of symmetry. It's also the x value of the vertex. How do we find that y value again? Nothing crazy, guys. We just fill it in. So f of negative 1. All right, so you don't write it as negative b over 2a. We got the number, and now we plop that in. Everywhere you have an x, x squared plus 2x plus 4. Please, right now, as confident as you are in your math ability, please pay attention to what I'm doing. When you really start the limit definition of a derivative, you will be finding the f of a sum, x plus something. When people need to find the f of x plus 4, x plus 7, x plus h. All of a sudden, everything you know goes out the window, and like, I don't know what the heck people start doing. Look what we're doing. Everywhere we had an x, 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 x. We're gonna make sure, safety first, put on that life preserver, those little fluffy swimmies over there. Put on your parentheses, safety first. And then inside of those parentheses, the square does not go inside the parentheses. The 2 does not go inside the parentheses. Again, no one showed you that. A lot of the times when you think math is hard and you make mistakes, it's because you're making up stuff. Stop making up stuff. Everywhere you have parentheses, which is where x was, x marks the spot, we're filling in a -1. In the future, when that's f of x plus triangle, you're going to fill in x plus triangle, x plus triangle, x plus triangle. And then you're just going to apply math rules. If you have a sum or a difference squared, we must expand properly. You might think of that as using, say, FOIL, right? You have to write it down multiple times. You never square each thing when you have a sum or a difference. No, again, no one showed you that. You could square each thing when you don't have sums or differences, when you have one thing, one big expression without any plus or minus signs. Sure. Not if you had a plus or minus inside. And here you would multiply. Make sure you just follow order of operation rules and carry on. So keep that in mind. When we get there, don't do anything weird. Do not. Don't you dare. Okay, carrying on. I leave f of -1. Kind of like in trig identities, how we only changed one side. I'm going to leave that the whole time because it gives me a full sentence for my final answer. It's really saying the function at -1 is blank, or the y value when x is -1 is blank. You get a full thought, you get a full ordered pair out of it. So let's keep going. -1 squared is 1, -2, plus 4. Fun fact, every time you find the vertex of a parabola, the ax squared and the bx will always combine to give you the opposite of whatever ax squared is. 1 take away 2 is -1. So we know we're on the right track. Plus 4, and we have that the f of -1 equals 3. Again, this really says when x is -1, comma, y is 3. -1, comma, 3. That's the vertex. All right. We have our vertex. We talked about that being our y-intercept. Every y-intercept has what in common? X equal to 0. So 0, comma, 4. We have a positive out front. That means our parabola is opening upward. Let's start getting a little bit of a graph of this going. So I am going to, I had graph paper, but I'm just going to kind of squish this over here. All right. I'm going to go to the left 1. I'm going to go up 1, 2, 3. There's 3. And that's -1. Going to put a point right there. That point is my vertex. Now, my y-intercept, yes, that's 4. However, and my axis of symmetry would be right here down the middle, obviously the middle. You can use your y-intercept to come up with another point on the other side of your axis of symmetry and make it a little bit easier to draw your parabola. If I only drew those 3 points, I'm going to have a bit of a small parabola. I want to go a little overboard here. So I went, think of the pattern I showed in the previous video. Out 1, up 1. Out 1, up the next odd number is 3. 1, 2, and 3. 1, 2, and 3. Out 1, up 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Out 1 and up 7. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. So if I connected all of those, nice and careful. give me? Okay. I have drawn a fairly decent parabola, quadratic function. Again, my vertex, this ordered pair, was -1, 3. I wanted to label a few more points. That right there would be -2, it was up one more, so 4. Careful. The left and right affects the first value of your ordered pair, and the up or down affects the second value in your ordered pair. Then I went out one more, so -3. From there, I went up 3. I was at 4, so now I'm at 7. I went out one more, so I'm at -4, but I went up 5, so now I'm up 12. That right there, well, we saw the y-intercept was 0, 4. Then I went out one more, so that puts me at 1, up 3, so I'm at 7, right? I went out one more, so I'm at 2, up 5 more, so I'm at 12, and so on. All right, so that is how we draw a fairly decent parabola using a lot of those things that I just pointed out to you. And remember how to identify one, remember how to find all of these points. Could you also just fill in 2 into this f of 2 and get 12? Yeah, you could do that. Go crazy, right? F of 2, 2 squared plus 2 times 2 plus 4. 2 squared is 4 plus 2 times 2, which is 4 plus 4. 4 plus 4 plus 4 is 12. Okay, we would have gotten 12. But who wants to do that for every number and then connect your points? Nobody. That's silly. If you have a better way to do it that way, right? So that right there is a full example graphing a parabola, which actually also doesn't have any x-intercepts because it's opening upward above the x-axis. So factoring would not be helpful in a case like this. And I hope that you were able to recall all of this information. I hope that you can remember this moving forward. I hope that you copied this down. Hope that it was helpful. If it was, thumbs up. If it was dumb and you hated it, thumbs down. Have a nice day.